What's going on and welcome back. Today we're gonna do Windows investigation. Previously, in one of my videos, we conducted Windows investigation and it was part of TryHackMe challenge. I'm gonna put the video in the description or at least in the video card so you can get access to it. It was the first part. This one, it is the second part and it's a bit different. In today's scenario, we are investigating a Windows that is infected with WMI Backdoor. Now, WMI stands for Windows Management Instrumentation, and it is a way to perform system actions based on specific conditions. The actions we call them the event consumers, and the conditions we call them the event filters. For example, a WMI backdoor needs two sets to run. The first thing is, as you can see, executes after a set time and on logon. Of course, these are examples, but this is what we call the event filter. So the backdoor will execute after a set period of time or after the user logs in, the user of the compromised host. Now, after the user logs in, after a set of time, what's going to happen? The event consumer will run. What is the event consumer? It's the action that's performed by the backdoor. An example would be prevents, the example that we are going to tackle today. The backdoor actually prevents process execution and actually retrieve payloads from command and control center. So that's the example we have today. Now, another thing we were gonna tackle is the scheduled tasks. So in today's scenario, there is a scheduled task that dump passwords every 5 minutes from the SAM database and store them in an output file. And after that, it executes PowerShell. Actually, the PowerShell command it executes is the blank PowerShell command. It doesn't do anything. It is just for demonstration purposes. Also, we have a listener scheduled as a schedule. Also, we have a listener running a scheduled task, and it is listens on port 1348. So an attacker would be able to connect to the machine on port 1348 whenever they want. And lastly, we have two malicious files. One is Trojan and one is advanced persistent threat. They are in the form of exe, and I believe these were retrieved from the WMI backdoor. All of that is for demonstration purposes. Nothing is real. So for today's scenario, we're using investigating Windows 2.0 from TryHackMe. And the challenge contains a whole lot of questions to answer. So it doesn't matter now how many questions do we have. Let's now jump to the investigation and see what is what. Okay, so this is the compromised machine, and the very first thing we do all the time, actually before I start, it's always good to have, when you conduct investigation or any sort of incident response, it's always good to have notes beside you. For example, here I have malware investigation notes, and here I go through what is actually laid down here. For example, analyzing processes, I see what I can run, what I need to pay attention to. For example, right now we are doing some sort of live response, right? The live response is sort of type of investigation that you would do after you have actually imaged the system. So right now we're gonna conduct an investigation on a compromised machine. This is actually part of an incident response process. And before you do the live investigation, you have to take an image, memory image, and disk image of the whole system, right? Don't conduct any sort of live investigation immediately on the machine. And I have stated that clearly in my blue team notes. For example, here, conducting investigation, it's important not to perform any operation on the machine before you do a full memory and disk copy, according to forensic standards. Forensic standards state that a full bit by bit copy of the RAM and disk should be performed in addition to any available snapshots. And after you do that, you start your live investigation. What we're doing now is live investigation, all right? Okay, so we have a couple of things to do. The first thing, we have some tools here created by the author of the room. We have process hacker, we have sys internals, and we have Yara scanner, which is Loki scanner. These are their rules actually, but we have Loki to use, match Yara rules on the system. We want to know what actually could trigger the Yara rules using the Loki tool. So now, when you close that, the first thing we open actually, I opened here the task scheduler. It's one part of the investigation, and also I opened the process. Now it's the auto runs, and now we're gonna open the registry editor. All of these are parts of your investigation. We're gonna need them when we define the malware and see what it does. So this is the registry key, registry editor, sorry. And now we will also go back to the tools and open process monitor. And also we will see if anything else we need to have. Okay, for now this is okay. All right. So if you go to task scheduler first, click on that, you'll see a list of all the scheduled tasks. Among the scheduled tasks, we have 2 tasks running every, as you can see, the first one, after it triggered, repeat every 2 minutes indefinitely. And the second one actually repeat every 5 minutes. Let's take a look at the first one. It's called flash update 22. If you take a look at the actions, this is the command that is executed when the event is triggered. Partial, Windows style, hidden, no profile, -C, and blank. So this is kind of partial command that does nothing. It's executed every 2 minutes. The next one called game over, and when you go to actions, take a look at the actions. It executes a file called MIM located at the temp directory, and what it does actually some sort of mimikatz command to dump the passwords to a file called O in the temp directory. So this is the first clue of our investigation. There is a scheduled task that dumps the passwords to an output file. But we're gonna find out where did this come from, right? So if you go now to the temp directory, the temp, as you can see, we have the MIM file executable, and we have a couple of files. We have WMI Backdoor, we have scheduled tasks backdoor, and we have NC, seems to be netcut, netbioscan, and XCMD. Now let's take a look at the first one, scheduled tasks backdoor. Now I believe this is the PowerShell script that has created the 2 scheduled tasks. Let's take a look at the script. Of course, this is for only demonstration purposes. Nothing is real here. So these are examples of running the tool actually. As you can see, this is the PowerShell script that's running every 2 minutes. Just popped up a while. Now, as you can see, these are examples of using the tool. And if you scroll down, let's take a look. See if there are any artifacts in the script, but I don't believe so. This script actually is run from the command line for one time, and these are examples of running the script. So basically invoke task backdoor, and here you specify the payload that you will execute using the task scheduler. So for example, invoke task backdoor, and then the payload, for example, is running the command in here, right? That's the first payload. The next command will be for running this command. So basically, when you run this script, we specify what are the scheduled tasks and their payload, and they will be created here. Okay, we uncovered the first clue of this challenge. Next, let's take a look at the WMI backdoor. The attacker would run this WMI backdoor from the command line and specify these variables in the command. So if you want to know what are the actions performed in the WMI script, we have to retrieve the WMI instances on the machine. We're going to do that later. But now it's enough to know that we have a WMI backdoor that performs specific actions. Let's scroll down and see if we have anything else. As you can see, we have here actions, right? The first action is launch beaconing backdoor. And the next one is kill process. So here you go, we have now two actions being performed by the backdoor. The first one is launching another script, and the next one is killing a process. Okay, let's find out what are these actually, what are these actions. To find out, we're gonna go back. We're gonna launch now. See, these are the scheduled tasks. So let's now launch PowerShell. And I'm gonna retrieve the list of WMI objects. We're gonna go to my notes and see what do we have in here about WMIs. Okay, let's use this one. So we're gonna retrieve the list of all WMI objects. So as you can see, get WMI. Let me make this bigger so you don't complain about the font. That's a bit too big. Properties, make this 24. Okay, so go back. This is the command, get WMI object. We specify the namespace. Normally it is root / subscription, but in the script, if you go back to the script, I spotted different namespace. Edit. Now see here the namespace is root /CIMV2. Let's copy that. Okay. And now we want to retrieve the event filters, right? Enter. Nothing. All right, let's switch back to subscription. So now these are the event filters, and as you can see, for every event filter we have the query being run. So the first one, event filter, let's scroll down. Superclass Dynasty. Okay, so this is the event namespace. And this is the query. Select asterisk from timer event where timer ID equal timer. This is the timer actually for after which the action will be executed. So now, as you can see here, we have another query. Select asterisk from win32 and the process name equal process xp64.exe. So now we know actually what was meant by the kill process in here. So if you scroll down, and you see in the list of actions, what keeps pops up. Okay. So now we have the action, as you can see, kill process. So the process actually is Process Explorer 64, which is Process Explorer for listing the running processes. If you scroll down again, we have another one. Select asterisk from MSFT event log event. The path is event log filter. Okay, so these are the events we have, event filters, WMI instances. Now we spotted actually what was the process that's being killed. Now let's find out what is meant by launch beacon backdoor. What is that action? I don't see it in here, unfortunately. So we're gonna use now an alternative way is to go to autorun, locate the WMI tab, and here we see also the list of WMI instances. We see the first one, kill process. If you right click on that, we'll take a look at what is the process being killed. So here it's not written. The next one, launch beaconing backdoor. Now, launch beginning backdoor is supposed to connect to a command and control, but it was stated by the room author that, as you can see here, proof of concept WMI backdoor is a crude WMI backdoor that doesn't include a C2 server component, used for demonstration purposes only and to demonstrate offensive WMI techniques. No further optimization will be performed. So yeah, we have an action, yeah, called launch beaconing backdoor. It refers to a script that's supposed to be retrieved from a C2 server, but based on the note, it's only for demonstration purposes. So now we know what is the objective of this script, and we know how it works. Okay, let's close that one and go back to the temp directory. So we now know what this does, and we know what this does, and let's take a look at this. So this is the netcut. If you go back to that scheduler in here, you see we have yeah, so this one here, take a look at this one, clean file system, and upon checking the action, as you can see, it runs the netcut PowerShell script that listens on the port 1348. So that is the objective of this one. The rest of the files are actually malicious files. We have this one seems to be backdoor or Trojan. The same for this one. These are exe applications. When you investigate the machine using, when you do an investigation, you're going to send these files to the reverse engineering department. They will conduct a full, thorough analysis on the executables and retrieve any artifacts found in these executables. All right, so now we know what happened on the machine, and we know how the infection just happened. Let's now jump to the questions and answer them. So, what registry key contains the same command that is executed within the scheduled task? Okay, so we go to the scheduled tasks. We see one command being executed, this one. If we want to locate the corresponding registry key, we have two options. The first one is using the autorun. Now we go to everything and we spot as you can see, the process C _C /temp /MIM, and above that we got the registry key. Alternatively, you can go to registry editor, right click, wait. So in view here, where is the find? And we type, for example, let's take a look at the stat scheduler. One string from the command. Sec URLSA. This is the Mimikatz URLSA. Let's search. As you can see, we located the registry key that's got stored after the command got executed, and this is the answer for this question. Okay, next one. What analysis tool will immediately close when you attempt to launch that? Now, this question, actually, we can answer the question without looking for the process. Based on the question, we saw that there was a process being killed by the WMI backdoor, and it was Process Explorer 64. And that's the healthy way to answer the question. If you haven't conducted the analysis we have done a while, you can just go to desktop and try to launch one of the sys internal tools. You will see that when you launch the Process Explorer, this is the one. You see now, it doesn't come up, right? All right, because it's being killed by the backdoor. What is the full WQL query associated with this script? All right, now we come to the scanning part. So after we identified the attack artifacts, now we want to know if there are other artifacts. Okay, so we can use actually something called the Yara scanner. We explained about how Yara works and what are the Yara rules and how to launch Yara scanners. In this scenario, we used something called the Loki that scans for indicators of compromise. As you can see, it's I run the command here, loki.exe, and I forwarded the output to the text file called output. Now, this command takes a while to run. Unfortunately, it has been running for like 1 hour, and until now I didn't finish. But anyway, I'm gonna open the file and retrieve the answer for the question. Okay, now we have the log here. So the question is saying, what is the full WQL query associated with the script? So what script? Of course, the WMI script. Now, you go back and you see here, this is the WMI query that is associated with the process name, Process Explorer 64. And that's the exact query why the process execution is failing. Okay, what is a script language? What is the script language? Okay, let's go back. To click on temp. It's clear that the language of the script is Visual Basic, right? Because if you take a look at the syntax, and if you want a hint, you can scroll down. See, it's saying VB script, right? It means this is a Visual Basic script. Next, what is the name of the other script? So we saw that there are two actions performed by the backdoor, or the WMI backdoor. Let's scroll up, look at these two actions. Yeah, see, the first one is launch beaconing backdoor, the next one is kill process. So that's the name of the script meant by the question. Next one, what's the name of the software company visible within the script? So now we go back to the script and locate any name for any company. If you scroll up, all the way up, keep scrolling down, see if we get any unique name. Seems like you have to take a closer look now with slower pace of scrolling. So as you can see, we have here 119.99 Antonin Fowler Motobit software, and this is the URL of the company, motobit.cz, and there is another one, motobit.com. These are for this question answer and the next question's answer. Next one, search online for the name of the script for question 5 and one of the websites from the previous answer. What attack script comes up in your search? So if you go back now to the temp directory, you see now it's WMI Backdoor, and if you search online for that name, you will find an exact script that matches the content of that script. What is the location of this file within the local machine? We saw it was under temp. What two processes open and close very quickly every few minutes? Okay, you may know the answer for that. We actually we see that every 2 minutes, every once in a while, we have two windows popping up for like 1-2 minutes and then leaving the screen here. To know what are these processes, let's take a look at let's monitor the process monitor here. So in the process monitor, what we will do here, we're gonna use a filter to match a specific process. Let's reset, type here process name, say MIM. You know, this is the process that's being launched every 2 minutes, and add that to the filter, apply. Wait, it should be mim.exe. I'm gonna remove this, add this one. See, that's the MIM, right? Popping up right now. It's doing something. Of course, we know that it is dumping the passwords from the SAM database, but that's the first one. Now we're gonna monitor the process in here using the process monitor. But anyway, we saw that the only two processes being repeated every 2 minutes or every 5 minutes from the task scheduler, as you can see, 5 minutes and 2 minutes. These were the MIM and PowerShell. What is the parent process for these two processes? Now we go to Process Explorer, Process Monitor, Process Hacker to find out about the parent process. All right, so now we set the filter. With the filter set, we can see we have the process name MIM, the operation process start, and the PID of the process. Now, if we go to Process Hacker, since Process Explorer is not working, we're going to need another one. We're going to use Process Hacker. So go to Tools, Process Hacker, and launch that. So, MIM 4924, the process here is started, right? And you can see that the parent PID from the details is 908. Okay, now let's go back to Process Hacker and locate that process 908, whose PID is 908. You see the process is the service host, which is a legitimate process, right? But unfortunately, it's being used for malicious purposes using the WMI. That's the danger of WMI, actually. It lets you use legitimate processes for dangerous purposes. So that's the parent process for the MIM, which is the first operation for the first of the two processes. So we saw that the two processes are MIM and PowerShell. Now we have to find out what's the first operation of the first one, which is MIM. The first operation using the filter we have just set in the process monitor, it was process start. Okay, inspect the properties of the first occurrence of this process. In the event tab, what are the 4 pieces of information displayed? Okay, go to properties. All right, so you have the parent PID, you have the command line, you have the current directory and the environment. These are the answers. Inspect the disk operations. What's the name of the unusual process? Okay. Although guys, most malwares do not perform any operations on disk. Most of the sneaky malwares perform operations on memory, and they run on memory. That's why disk operations are not important in the investigation, although they are part of it, but I don't think they are important in today's malwares. Okay, so now we conduct the investigation on the disk operations. We go to Process Hacker and click on disk. Let's see if there is something abnormal. We have the Loki running. We have system, service host. So up until now, I got nothing. But if you wait for a while, you will see that the answer is no process. No process is not, it doesn't mean that there is no process, of course not. But it is the name of the unusual process. But for some reason, it's not showing here. Let's wait for that. Loki is taking up much of the space because now it is scanning the machine. Okay, we're gonna leave that for now. Run Loki, inspect the output. What's the name of the module after initialize? Okay, let's go now to the Loki output. I hope it was finished, but I think from this, Loki hasn't finished yet. Anyway, let's take a look at the output. Let me close the file and reopen the file again, since it's being updated real time. Okay, let's see here. Now what's being asked? Run Loki, inspect the output. What's the name of the module after? Alright, run Loki, inspect the output. What's the name of the module after? So it's always WMI scan. Regarding the second warning, what's the name of the event filter? Alright, let's take a look at the output now. So we scroll down to the warnings. This is the first warning. And the first warning here, we about the event filter on the WMI, and it is about the timer. The second warning, also event filter, and it's about the name of the filter is process start trigger, which is the one that stops the process explorer.exe. That's the answer for the second question. For the fourth warning, what's the class name? So now we have the first warning, second, three, fourth. That is the class name, filter to consumer binding. What binary alert has the following as first bytes? So to find a binary, we're gonna have to search inside the file because it's very hard to parse through everything in here one by one. Gonna find okay, now we found one match. If you take a look now at the alerts section, so here's an alert about the executable MBT scan, and these are the first bytes. Now if you take a look at the reason one, why this file triggered an alert. The first one, file name IOC matched, pattern known bad, dual use classics. The next one, malware hash type. So the first thing that triggered the IOC actually is the hash, the file name, sorry, the file name. And the next thing, or the next IOC, as you can see, malware hash type SHA-256. That's the hash known for emissary, bandit tools, and malware. So the answer for the question is, this is the executable name, and the reason for that is known bad or dual use classics, and of course the IOCs are the file name and the SHA-256 hash. That answers this question and this question. What binary alert is marked as APT clocked? APT clocked. All right, let's see now. Let's search for the APT, see if we have any string on that. We have one. So in the alerts, we have one alert over the file p.exe. These are the MD5. The reason for the first, or the reason for the trigger, as you can see, the file name IOC matched a pattern. So the file name, and also the next reason is the APT clocked PS exec. So it matched one rule and a file name. All right. Next one. What are the matches? The matches, if you go back, see the matches in here, scroll down, the matches section, the BS exec, and this is internals. Now, what binary alert is associated with something Windows.dump found in ctemp? Okay, now let's search for the extension dump. Okay, so we have one hit. The warning is about the PowerShell script that performs task scheduling, as you can see. And the reason is that, the reason one, Yara rule match PowerShell SUSP parameter combo. The description detects PowerShell invocation with suspicious parameter. Okay, and the matches are, these are the strings, dash encode, dash no profile, and dash EP bypass. These are all artifacts of a malicious, say to me, PowerShell script. And then we have an info about that, scanning memory dump file. So that is the answer. This is the script. What binary is encrypted that is similar to a Trojan? Now if you scroll down one more section, you will find that there is a hit on a file called xcmd, and the reason, if you read the reason, it's saying Yara rule match XOR 4-byte key. So that binary uses XOR encryption. It takes an executable encrypted with 4-byte XOR. There is a binary that can masquerade itself as a legitimate core Windows process image. What's the full path of this binary? Now, previously, guys, we saw that the service, that's this one, what is hacker? Yeah, we saw that the parent process for the MIM file was the service host. right? But actually, there is another one on this machine that's used for malicious purposes. But that's the name of the process, or the process that actually is legitimate on Windows but can be used for malicious purposes. Now, what is the path of this binary? We can locate the path from the IOC log file. Let's see here. Well, let's search for service host. Okay, we have one alert. See this alert in here on this file, service host, and the reason is the file name match a pattern, and the reason for that, as you can see, stuff running where it normally shouldn't. Of course, the service host should not run under C users public. It should run under C Windows System 32. So that's unusual appearance of such a process. What's the full path location for legitimate version? We know it is C Windows System 32. What's the description listed for reason 1? We saw it was stuff running where it normally shouldn't. There is a file in the same folder location that is labeled as a hack tool. What's the name of the file? Scroll down one more. Nothing, because the scan is still running. Let's search for hack tool. Okay, so nothing in the output file. The reason for that, as I said earlier, because the scan is still running. Now, if you go to the temp directory, you see there is a file called, let's see, go to public, no, go to C users, public, and locate the malicious service host. Beside that, there is a JavaScript file. Now, this is the JavaScript file intended for the answer of this question. What's the name of the Yara rule match? Unfortunately, because the scan isn't finished yet, I cannot retrieve the the Yara rule name. But we're gonna see if I can find a match. ENUS. Nothing yet because the scan hasn't finished. But if you search with this name, you will find that the rule name was Cactus Orch, which binary didn't show in the Loki results. Alright, now if we search for MIM, we have a match, but it is on a similar file, which is the output file, by the way, MIM out. MIM. So you see, we don't have matches on the file name itself. And the reason for that, when Loki scan or when Yara scan doesn't detect a file that you know it is malicious, it means that the rules in the rules on the tool, right, don't include any IOCs for that file. So we're gonna have to study the IOCs of the MIM and add them to the rules file. So what we can do, we're gonna close this one and go to command line, command prompt. I'm gonna use PowerShell, cd back, cd temp, and now we have the MIM. So for the Yara scan to be able to detect this file, we're gonna need to find the IOCs for the MIM and add them to the rules, to the Yara rules of the Loki. So one way to do that is to run strings on MIM, but this will result, I know. So we need to run the actual the CMD in here. So R, okay. Make this a bit bigger. Properties 24. Okay. So cd back. So we have the MIM now. All right, let's try to extract some IOCs from the MIM file. One way to do that is to run strings 64.exe. We're gonna have to cd to the directory of that tool actually. So we're gonna see where it is. Let's see. Desktop, sys internals. So we have the tool here. Okay. cd users administrator tools desktop. See, we have the tools directory. Under that we have sysinternals, and then we're going to be able to launch strings now. Strings 64. Oh my god, these. Okay, specify the location, which is temp, and then the file name mim.exe. Right now we will run strings on the file, but this will result in a very huge output. So we're gonna need to find a way to extract the artifacts using another filter. So we're gonna use the find strings using the find string, sorry, in Windows. So find str, and he will specify what we are looking for. For example, let's type exe. So we got one artifact, m.mk.exe, right? We can add this to the list of IOCs. You can also see if there are other instances of mk by searching for mk. So we also have mk ps1, mk exe, and also have mk resources. So after we have found two IOCs, we're gonna need to find another IOC. So basically a tool such as MIM that dumps the passwords from the SAM database, it doesn't actually connect to the internet. So there is no anything such as a domain or IP as an IOC in this file. So we're gonna need to look for something else like the version of this file. So if we use a regular expression to search for something such as v2 or v1, no v1, v2. So when we search for v2 here, we see the version of the application. That's also another IOC that can be used and added to the Yara rules. Now we can take all of these, the executable name, the PS1, and the version, and add them to the Yara rule file of the Loki. So we're gonna go to tools, locate Yara, locate Loki, and then locate signature base, going to Yara. And as you can see, we have the Yara rules used by Loki. We can add a new one, and say, for example, mim.yar. So now if we open this one, where is that one? We're gonna need to find that. Okay, so open this one, and now we create the Yara rule file. For example, you can just, if you want to create a Yara rule file, and not from scratch, you can open one from here using Notepad, and you see an example, right? So you have the strings, and in the strings we defined the actual IOCs. And also we have the rule name. So let's do that. Let me go back to my notes and retrieve the formula of the Yara rule file. So let's go to, so here, let's take this one and then create it like that. So now we say MIM detector, the author name, and here the description, detect malicious WMI exes. I'm gonna name it like that. Created today is 02 01 2022. Now the strings we have, the first one, if you go back to the command line, so we have the version, right? So I'm gonna copy that and add it here. Name it as version. Next one is name, or say mk name mk.exe, and the last one, let's copy the name and say okay, mkps and name it mk.ps1. Now we have created all of the IOCs for the mim.exe. I'm gonna add them here in the condition. So add the variable names, version, and mk name and mkps. Save as, all files. Okay. So we have the Yara rule file now. Now when you run the Loki scan, it will find the file and it will just show that in the output, the log output you have just created. So for now, everything is finished. I hope you guys found that helpful, and see you in the next video.